Now that we've learned a little bit about the idea behind inverse functions, let's practice finding inverse functions when given an actual equation. In the last video, we saw how we could find an inverse from a graph or a table of values. So now let's embark on finding inverse functions really, like I said, algebraically or from an equation. So we'll do a first example. We'll see if we can summarize our process used and then apply that process again. So let's see if we can find f inverse. So the notation again is a function notation with a little -1 exponent. So that's the mathematical notation for the inverse. And let's say that we're given function f to be something linear. So how about we take 2x plus 5? So f of x equals 2x plus 5. So I'm going to go ahead and just rewrite the function again below and walk through kind of a very intentional process so that you can always use this process yourself. The first thing I'm going to do is just replace f of x with y. We know those are interchangeable. F of x and y both hold the position of the output of the function. And as I move through these steps, I'm going to just try to kind of jot some notes on the side. A lot of people refer to this process as the four-step process, so I'll number the steps. So replace f of x with y. And I said I would do this at the end, but maybe it makes more sense to just capture those steps as we go. The next step is actually where we're switching to the inverse function, and I think this idea will make sense to you. Basically, the second step is swap x's and y's. And this will make sense from what we've done graphically or from ordered pairs. So anytime we see a y, it becomes an x. Anytime we see an x, it becomes a y. And I just switched colors because technically speaking, what I wrote in orange is the inverse function. We are going to go a couple more steps just because the way that that orange line is written is not your standard function notation. So as soon as we've swapped the inputs and the outputs, I personally like to change colors just to remind myself, okay, now I'm actually at the inverse function. But looking at this line, you all would agree it doesn't quite feel like a normal looking function. For one thing, most functions that we've worked with start with y equals or f of x equals. So we can make our function look that way by going through a series of steps to solve for y. So this next step is truly algebraic. We're just going to take the orange equation and manipulate it to isolate y. And we all do our algebra dance a little differently, so don't feel like you have to do yours the same as mine. But I'm going to go ahead and subtract 5 from both sides of the equation. And then I'll just divide both sides by 2. So x minus 5 divided by 2 will equal to y. And just to help our heads, this is a small step, but I'm going to say instead y equals x minus 5 divided by 2, just so it begins with y. So we're pretty much there, but I told you this process was 4 steps. So the last step is just a notational thing, and that is to replace y, you probably can guess, with that inverse notation, so f inverse of x. And that will be a good stopping point for us. So I'm going to say f inverse of x instead of y is equal to x minus 5 over 2. And that would be a great place to end. This is a nice looking inverse function. Typically folks ask if we can write it other ways, and we sure can. So before we call it quits on this one, let's just offer up another way to write it. Some people prefer to bust this into 2 fractions. You can see that we've got x minus 5, so 2 terms in the numerator. So it's not uncommon to hear people write this as x over 2 minus 5 over 2, just by breaking it into 2 fractions. Or for that matter, you may even see folks take this same inverse function and write it as 1/2 x minus 5 over 2, just to separate out the x term a little bit. So please take your pick. All three of those solutions we just wrote down are equally good in my mind. So do what feels most comfortable. So that's our first example of finding an inverse function. And this four-step process that we wrote, oops, looks like I erased a little bit, will apply to every problem you guys encounter where it says find the inverse function when you're given the equation for f of x. Let's just go through those steps again and then we'll try another example. So we always begin by replacing f of x with y. When we swap x's and y's, we've technically arrived at the inverse function, but we go through a couple more steps to make it look more standard. So we solve for y, and then we swap out y with f inverse of x. Nice. Let's try another one. In this next example, let's again find f inverse. This time, let's say that we're given f of x as, let's make it more of a rational, just to play around with that a little bit. How about x over x minus 7? All right, so we're going to find the inverse. Same process. I'm just going to start by rewriting my function below. You might not feel the need to do this, and then I'll dive into the 4 steps. So let's replace f of x with y. There's our first step. Then let's work on swapping our x's and y's. So replace f of x with y. Next, we're going to swap the x's and the y's, or if you feel like that's not super clear, we're basically saying anytime we see an x, replace it with a y. Anytime we see a y, replace it with an x. For me, this is where I like to change the color that I use, if any of you similarly like to work with different colors, because it's really at this step that we've arrived at the inverse. Now we'll just go through some steps to make it feel more standard function notation. So now we've got to solve for y. And I chose this example just because the algebra is a little different than the last example. So solving for y here could feel a little harder because, as you're noticing, there are 2 y's in the equation. So this x on the left-hand side, remember, can be thought of as x over 1. The only reason I'm writing it that way is when I say cross multiplication, most people get kind of happy. It's not a bad process. So I'm just going to cross multiply to start solving for y. When I cross multiply, I'll show some steps here. I'm going to be multiplying x times the quantity y minus 7, and then I'll just be multiplying 1 times y. So I like cross multiplication as a first step towards solving because right away we get rid of the fraction feel, which is kind of nice. I'm just going to distribute now on the left-hand side to get xy minus 7x, and that's equal to y. So we know algebraically, if we're trying to solve for y, we've got to get all the y's on the same side. So as a next step, I'll keep the negative 7x on the left, and I'll move the xy term to the right by subtracting. So I basically subtracted xy from both sides. It's a little messy, so I say out loud what I did there. And then if our goal is to isolate y, this will probably feel familiar from your previous algebra experience, we need to factor out the y that we're solving for. There are 2 y's on this right-hand side, so if we factor the y from both terms, that would leave simply a placeholder of 1 for the first term and a negative x for the second term. So just a reminder, when we say factor, we can always check our work by distributing the quantity back in. So double check that y times 1 recovers the y term, and y times negative x recovers the negative xy term. So we factored out the y that we're trying to solve for. And let's go ahead and finish this off. It looks like to continue isolating our y value, sorry, I'm trying to move my screen up. There we go. We can divide both sides by 1 minus x. And I would say that we've pretty much solved for y. It helps our heads typically just to flip it around and put y on the left-hand side. So I'll go ahead and do that for those of you who like that step. And then last but surely not least, that fourth step was basically to replace y with the good inverse notation, f inverse of x. So to wrap this guy up, we will say f inverse of x is equal to negative 7x over 1 minus x. And that would be the inverse function. So in this video, we've looked at 2 examples. I'm going to pause, run out, pull some graphs just to show you that the 2 examples we did can be checked by that idea of reflection that we brought up in the first video. So I'll be right back. All right, so I went ahead and graphed the 2 different examples we did. This first graph is showing our first example where we had f being a linear function, and then we found the orange line as the inverse. So you can just see that symmetry again. I really like this. Visuals help kind of connect the dots for me, and so I'm wondering if some of you may also benefit. So you can see that our work looks good because the blue line and the orange line are reflections across that red dashed line that we talked about in the first video, the line y equals x. So that's kind of cool. And then our second example, the graph is a bit more crazy, but it also checks out. So our second example, we have in blue the function f. It was a rational function. And then we had found together the inverse function shown in orange, which is another rational function. And although these 2 graphs are a bit more complex than the linear graphs in the previous picture, we still see that reflection element, right? So I'm kind of focused on maybe this half of the graph for a moment and then the other part of the graph to see those symmetries. So up top, we can definitely see if we held a mirror on that red dashed line, we would get the mirror image. So pretty neat stuff. We'll do one more video to connect a couple last things on inverses and then we'll call it good.